dear children. Hope you all are fine. Welcome you to the third module of physics from the chapter Gravitation. Hope you watched the first two modules. The law that we discussed in our previous module was universal law of gravitation. Hope you remember the statement. Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. This force is acting along the line joining the centers of the two objects. The equation F is equal to G m1 m2 by d square, where G is the gravitation constant and m1 and m2 is are the masses of the two objects and d is the distance between the two objects. So what did we understand from this law? We understood that everything in the universe is pulling every other thing. Moon, earth, sun, all these heavenly bodies are exerting force on each other. They are exerting equal and opposite forces on each other. It is very interesting to think that we as objects having mass are also influencing the universe. How? Wherever we are under the gravitational pull of the objects surrounding us. Maybe a pen or a book kept near to us, or a person who is standing near to us, or a heavenly body that is in space. So in this module, we are going to do the numericals related to the universal law of gravitation. Now let us just analyze the characteristics of gravitational force. Children, let us quickly go through the characteristics of gravitational force. It is an attractive force. When we drop a ball from a height, it is attracted by the earth due to its gravitational force. It's a force at a distance. For gravitational force to act, we need not keep the objects in contact. That means gravitational force is a non-contact force. Forces are equal and opposite. For example, the force that is exerted by the moon to the earth is the same as the force exerted by the earth on the moon. But we have discussed earlier why we see the moon revolving around the earth, because the earth has a higher mass than the moon. Next, it's independent of the intervening medium. Whatever be the medium between the two objects, it doesn't affect the magnitude of gravitational force between those two objects. It's the weakest force in nature. Compared to the other forces like electrostatic force, nuclear force, gravitational force is the weakest force in nature. It's a long-range force. If we increase the distance between the two objects, the force between them never becomes zero. We know that gravitational force is an inverse square force. That is, force is inversely proportional to the square of the distance. More is the distance, lesser will be the force. But the force will never become zero. It acts along the line joining the centers of two bodies. It's not affected by the presence of other bodies. If we think about the gravitational force between Earth and the Sun, there are many other celestial objects between them. But the gravitational force between the Earth and the Sun will be constant. It won't affect the presence of other bodies. Hope you understood. Question 1. How does the force of gravitation between two objects change when the distance between them is reduced to half? So children, here we are just going to do it and we are coming to the answer. So we know according to law of gravitation, F is equal to G m1 m2 by d square. So when the distance is reduced to half, that means d, you can see here d dash, or d dash is equal to d by 2. Our earlier distance, if you assume it as d, the new distance is the half of the earlier distance. So d dash is equal to d by 2. So when distance changes, the gravitational force between the two objects also change. So the force, the new gravitational force F dash is equal to G m1 m2 by d by 2 the whole square. So in the place of d, we are giving d by 2 the whole square. So the equation gets modified as G m1 m2 by d squared by 4. That 4 comes in the numerator, so it becomes 4 into g m1 m2 by d square. But children, g m1 m2 by d square, look the first equation, g m1 m2 by d square is our f. So we get it as 4f. So we found out that the force becomes 4 times. So when the distance between two bodies is reduced to half, the force becomes 4 times. Question number 2. What is the magnitude of gravitational force between the earth and a 1 kilogram object on its surface? Given mass of the earth is 6 into 10 raised to 24 kg and radius of the earth is 6.4 in 10 raised to 6 meter. So children, here we have the two masses. One is the mass of the earth, that is 6 into 10 raised to 24 kilogram, that is m1. Mass of the object on the surface of the earth, that is m2, is 1 kg or 1 kilogram. So radius of the earth, r or d, we can take it like that. So that is 6.4 into 10 raised to 6. So we are going to substitute in our equation, f is equal to g m1 m2 by d square. So value of g, we know it is 6.67 into 10 raised to minus 11 into m1, 6 into 10 raised to 24 into 1 divided by d square, that is 6.4 into 10 raised to 6 the whole square. So when you multiply all the numerals, that is 6.67 into 6 into 1 into, there is a 10 raised to negative 11 and there is 10 raised to 24. So you know a raised to m into a raised to n is equal to a raised to m plus n. That is 10 raised to minus 11 into 10 raised to 24. So how will you do this? That is 10 raised to 24 minus 11. That becomes 10 raised to 13. And from the denominator, we have 6.4 into 10 raised to 6 the whole square. So 6.4 the whole square into 10 raised to 6 the whole square. What is 10 raised to 6 the whole square? A raised to m, the whole raised to n is equal to a raised to m into n. You have studied children in mathematics. So it becomes 10 raised to 12. So from the denominator, the 10 raised to 12, when it comes to the numerator, it becomes 10 raised to negative 12. And finally, when we do this, that is 6.67 into 6 into 10 raised to 13 into 10 raised to minus 12, divide by 6.4 the whole square, you get it as 9.8 Newton. So 9.8 Newton, or the force that is exerted by the earth to pull a 1 kilogram object, is 9.8 Newton. Question number 3. What happens to the force between the two objects if, the first question, the mass of one object is doubled, the second, the distance between the objects is doubled and tripled, the third, the masses of both the objects are doubled. So here we have 3 sub-questions, so we will discuss one by one. So the first question, the mass of one of the object is doubled. So we know that if there is change in the mass, there will be sure a change in the gravitational force between the two objects. So we have the equation, the gravitational force F is equal to g m1 m2 by d square. Suppose m1 is doubled, that means m1 becomes 2m1. So the new force, let F dash be equal to g 2m1 into m2 by d square. In the place of m1 we are giving 2m1. So the 2, the constant, we are taking it outside and we are writing 2 into g m1 m2 by d square. So g m1 m2 by d square is our force. So the new force becomes 2 times the old force, or we can say the gravitational force will also become doubled if we double the mass of any one of the object. Children, the same question, second part. The distance between the objects is doubled and tripled. So the question itself has 2 parts. Let's look one by one. A part, the distance between the objects is doubled. That means d becomes 2d. So we know that when the distance increases, the force should decrease, the gravitational force. So here in the equation we are substituting, that is F is equal to g m1 m2 by 2d the whole square. It becomes g m1 m2 by 4d square, and we are taking the constant, that is 1 by 4 into g m1 m2 by d square represents the original force F. So what do we see, children? The new force becomes 1/4 of the original force. The B part, the distance between the objects is tripled. So that means D became 3D. So in the equation when we substitute the new force, you can see it becomes the 3D the whole square will become 9D square. So 1/9 into the original force, that is F. That is the new force became 1/9 of the original force. Last part of this question, number 3, the masses of both the objects are doubled. That means M1 becomes 2M1 and M2 becomes 2M2. So when we substitute, see children, we get G 2M1 into 2M2 by D square. So 2 into 2, 4, that constant we take it out and we get 4G M1 M2 by D square. And G M1 M2 by D square represents the original force F. So the new force becomes 4 times the original force. Anyway, we know that as the mass increase, the gravitational force also increases. Children, we have the homework question that was given, I think, in your first module. Sorry, in the second module. The mass of the earth is 6 into 10 raised to 24 kilogram and the mass of the moon is 7.4 into 10 raised to 22 kilogram. If the distance between the moon and the earth is 3.84 into 10 raised to 5 kilometer, find the force exerted by the earth on the moon. Given G is equal to 6.673 into 10 raised to negative 11. So mass of the earth, we take it as M1, 6 into 10 raised to 24 kg, and mass of the moon M2 is 7.4 into 10 raised to 22 kg. Distance D is taken as 3.84 into 10 raised to 5 kilometer. Kilometer we have to convert into meter. You know children, 1 kilometer is equal to 10 raised to 3 meter. So when we take the total distance in meters, we get 3.84 into 10 raised to 8 meters. 10 raised to 5 into 10 raised to 3 becomes 10 raised to 8. So when we substitute in our equation, we get F is equal to G M1 M2 by D square, giving all the values. When we give all the values, you get the answer as 20.1 into 10 raised to 19 newtons. Hope you got this answer. Confirm it. Children, there is a homework question. The gravitational force between two objects is 6 Newton. Find the new gravitational force between the objects when, first part, if the distance between the two objects is doubled. If the distance between the two objects is halved, and if the masses of one of the object is doubled. So go through the numericals that was discussed here and try to do this in your notebook. We'll discuss the answer in the coming class. So the notes that are to be written in your notebook. The first, state the law of universal law of gravitation. Second, derive a formula to find the gravitational force of attraction between any two bodies in the universe. This one we discussed in our previous module. And all the numericals discussed in the video should be written in the notebook, including the homework answers. So hope you understood the numericals. Stay safe. Thank you.